Well, good morning, everybody. How are you? Oh, good. Good to see you all. I'm so glad to be here. Look at this. We're in Greece. Oh, most of us come here for vacation. I get to come here for business. Somehow, I did that wrong. Huh. So I did it the wrong way around, but that's okay. I'm still going to have fun. I'm just so glad to be here. Look, can we all take a photo, please? Is that okay? Can we take a selfie? Is that okay with you? Okay, very good. Okay, everybody, I'm going to turn around, and I'm going to take a big old selfie, and then I want you to all say, open source, and then smile, and it'll be fine, okay? All right, ready, steady, open source. Oh, thank you very much. I appreciate that, my friends. I am going to take that photo, and I'm going to put that on the refrigerator, and I'll show it to my daughter, and I'll say, see, they listen to me. That's a Chris Richardson joke. I love that joke. Okay, my friends. Very good. Let's get underway. My name is Josh Long. I work on the Spring team. I am a Spring developer advocate, a Java champion, and a Kotlin Google developer expert. And more to the point, I'm at your service. So should you have questions, comments, whatever, don't hesitate to ask, right? I want to help you if I can. I'm online. I've got a YouTube channel. It's not great. It's okay. Could be better, but it's there. Coffee software, right? I love coffee and I love software. So find me online. I'm on the internet. I'm on Twitter. How many of you are on Twitter? I'm just curious. Still, who's still on Twitter? Yeah, I'm on Twitter. It's burning down. So in the meantime, if you're on Twitter, great, find me there. If you're on Mastodon, I'm there. Whatever, just find me online. I'm very online. Also, the code for the presentation that we're going to do today is right there on GitHub. So find that as well for your own references for later. Now, my friends, today we're going to talk about Spring Boot 3.0, which just came out last November, right? 3.1 will come out this month, May, later this month. You'll see the next point release of Spring Boot. And we're going to talk about some of the big themes, some of the big features in Spring Boot 3.0. This is a huge release, probably the biggest release. In fact, I mentioned that it came out last November on November 24th. And the reason I can remember this is because that was a public holiday. It was a holiday in the US called Thanksgiving. Thanksgiving is a big holiday for a lot of us, and it's very fitting to me that this release would be released on that holiday. The first release of Spring Boot 1.0 back in 2014 was on April Fool's, right? And so two very big releases on two very completely unrelated holidays. I thought that was always very funny. And it's kind of fitting that it came out on that holiday because to me, the 3.0 release is bigger in some ways than the 1.0 release because of the new implied opportunities. You see, Spring Boot 3.0 brings new capabilities and features, of course, but also new baselines, right? So, and new promises, new hope, So we're going to go here to my second favorite place on the internet, start.spring.io. How many of you know about start.spring.io? Very good. We're going to build a new application here, my friends. The first choice that we have to contend with, the first thing that we have to look at is what build tool we want to use. And you might have noticed that the default these days is Gradle, right? Gradle and Groovy or Gradle and Kotlin. Me personally, I prefer Gradle and Kotlin, but I guess it really doesn't matter. For this year, for 2023, my New Year's resolution was that I'm gonna learn Gradle and lose some weight. And I'm definitely learning Gradle. It's going well, right? It's going well. So that's good. My friends, we also have to choose what version we want to use. I'm going to use Spring Boot 3.0, and then we need to give our thing a name. So I'm going to call this Service. It's because I'm really good with names, very good. I'm like my father. My father was very good with names as well. We had a little tiny white dog that appeared at our home when I was a little boy, and my father named this dog White Dog. And then, like 10 years later, that dog disappeared. We don't know. Maybe he went to a farm upstate. I don't know. And then another dog appeared there, another little white dog. And so my father named it Two. Not sure if that was T-W-O or T-O-O. Either way, Two, right? And so my mom always says that I should be very lucky. I should be very happy that she named me and not my father. Because you can only imagine what my father would have named me when I was born. So, friends, we have also down here the choice of what version of Java we want to use. And frankly, my friends, this is kind of a test for intelligence. You see, there are 4 radio boxes here, but only 2 valid choices. Only 2 valid choices. Java 17 is the required baseline for Spring Boot 3. You need to use Java 17 to use Spring Boot 3 and Spring Framework 6. It is required. You can use anything later, of course. Remember, Java 21 comes very soon, in a few months, right? It's coming very, very soon. And that new release will be the new long-term supported version of Java. 17 is the old long-term supported version of Java. Java 17 and later are amazing. They're amazing. They're technically superior in every way. They're faster, more syntax rich, more operations ready, more secure, more performant, just technically superior in every single conceivable way. They're also morally superior. You won't like the look of sadness in your children's eyes when they find out that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 17 or later. Now, friends, remember, you could choose these other ones, but that would be the wrong choice, right? It's not acceptable to choose these versions of Java in any scenario except when you're trying to show people what not to do, right? Good. So I'm happy with my selections. Now we have to add some dependencies. Oh, yeah. Good stuff. Good. Let's add some dependencies. We're going to add H2. We're going to add the actuator. We'll add some web support. We'll add the GraalVM-native image support, right? GraalVM-native image support. H2 web. We want Spring Data JDBC, right? There we go. And I'm just, there's some very boring, very basic, very common selections. Let's go ahead and load those up in our IDE. Okay, and it doesn't matter what IDE you use, so long as it supports the build tool and the version of Java that you're using, in which all of them will, right? This is not a new thing at all. So we're going to load this up. Okay, wait for it to download the internet. Oh dear. Oh, good. All right. All right, good. So here we go, service. And we're just going to build an application that writes data to the database. Very, very typical application. So the first thing we're going to do is we're going to create a record, right? Record. And this is another nice feature in new versions of Java that I really like, right? I love this. It's just very concise, very easy to understand, right? Very, very convenient to see what I'm doing, right? And then I can create a repository to store data into the database. So I'll say extends CRUD repository, managing instances of type customer whose primary key is of type integer. And then I'm going to have some SQL in my database. I'm going to create a schema. So I'll go over here and create a new file called schema.sql. And there I'll just say create table, customer, and then ID, serial, primary key, and then name varchar 255 not null, right? Very good. Very simple SQL schema. And then we're going to create a new file in here called data.sql. Here we are. And we're just going to write some data into the database. So insert into customer, name, values. And we're going to put some people who are on the Spring team, right? Amazing people. We've got Yu Xin. Let's see. We've got Olga. We've got Dr. the good, the great, the amazing Dr. Sire. We've got Stefan. Let's see. Oop. Come on. There we go. We've got, I have forgotten the semicolons. Okay. We've got Jurgen, right? Some other people. Who else? Oh, me. I'm on there. Who else? We've got Madura, and we've got Violetta, right? There we go. So we've got a number of people on the Spring team. We've got our SQL table. And now I want to build something that will show us the data when the application starts up. So I'll create an application listener that will listen for the application ready event, right? And it's just a Spring Bean that'll get called back when the application starts up. And I will use this to then inject my repository to ask questions, right? I'll say, okay, repository.findAll.forEach. I'm just going to print out the data. This is nothing special. You've seen this kind of stuff before. This obviously can be turned into a nice little Lambda. Let's go ahead and restart that and see what happens. There we go. There's our data. You see that? It worked. It worked. Of course it worked. It was a demo. It was always going to work. So there's the data on the command line. It worked. Good. Now I want to build a simple HTTP API. like this, controller, like that, and maybe I'll say response body, class, customer, HTTP controller. I don't want to offend the Restafarians, so I'm just going to call it an HTTP API. It's not, pure REST per se, is it? So I'm going to create an endpoint here called customers, and actually, this is going to return all the customers. In order to do that, I need to inject my customer repository, like so, into the constructor, and I'll say return this dot repository dot find all. Very good, very, very, very simple kind of thing. I also want another endpoint here that returns the data by name. Okay, so customer's name, iterable, customer by name, and this is a path variable, so very simple, straightforward thing. Path variable, string name, voila. Okay, return this dot repository dot find by name, passing in the name. Okay, there's this right here, and of course the nice thing about this is you can just hit enter and have the IDE build it for you, so that actually will work just fine. Okay, good. So let's go ahead and restart that. That should work. We should have an HTTP endpoint with data in it. Curl HTTP localhost 8080 customers, and we've got Madura, for example. Okay, there we go. We got some data back. It worked. Good. No big deal. You've seen this before. Not special. But I want to make my code production worthy. That's important, right? Everything that we do, we should be focused on building production worthy software. So the first thing I want to do is make my API just a little bit more intelligent with validation, okay? When I pass in a name, we know that the name must start with an uppercase letter, okay? So let's say car at, we can say character.is uppercase, and then, the name must be uppercase, okay? Something like this. Now, what happens if this is not correct, if the validation doesn't match? It's going to throw this exception, and I need to handle that exception. Now, if I run this service with that validation in place, let's try it here. Let's say lowercase m, right? So m has to be uppercase, but it's not. I get this error, right? And this error it's fine, it's okay, it's generic. The problem is that this error is unique to Spring Boot. And I have not confirmed yet, but I've heard that it is possible, in the same way that we all agreed many years ago that the possibility of the Higgs boson particle was real, right? I've heard, but scientists have not confirmed, that some people are building applications using something besides Spring and the JVM. And so for those cases, in those instances, in those hypothetical situations, you would want a consistent error across your services. And so to that end, we have the problem details RFC. Now, this is a standardized way to represent errors. It's a very simple little specification. You can use it, no big deal. And I want to enable that support in my Spring Boot application. So I'll go here, and I'll say problem details, okay? This is a new feature in Spring Framework 6 and Spring Boot 3. So here we go. We're going to go back to this, and I will now, it'll throw an exception, but now I can create a problem detail representation. I want to control how the error handling in my application is done. So what I'm going to do is I'm going to create a component that catches all errors in the application, right? And it's going to be a controller advice. This is not new. You've seen this before, I'm sure, right? Public problem details, okay? And I'll just say handle, and we want to handle which error? We said the illegal state exception, right? So illegal state exception, ISA, okay? And here, I'll say var pd equals problem detail dot for status, and I'll say HTTP status dot bad request dot code or value, and I'll say pd dot set detail ISA dot get message, and I'll return pd, okay? So there's my representation of the error. I'm just going to return that whenever there's an exception anywhere in the code that has that type, okay? So now I'm controlling how the representation happens. Okay, small thing, but it's nice. It's very important. Another thing that I might want to do is to capture the context associated with the error. And so to do that, I can inject the current HTTP servlet request. Again, is this special? No, except it kind of is. You see, one of the big things about this HTTP servlet request is that the package is different now. Right? If you've ever used the servlet API, then you know it used to live in javax.servlet.http. And they've changed this. And it's not a technical problem, it's a political problem, right? Lawyers got involved, and about 5 or 6 or 7 years ago, Oracle just stopped responding to the community for any changes to what was called Java EE, right? Eventually, after enough time, like 6 months or something like this, Oracle came back to the table and they open sourced it. But there was one requirement. They open sourced Java EE to make it open, right? To make it truly open and fair. But they had one requirement. Any changes that they make to Java EE, any types that change, new interfaces, new types, new methods, deleting methods, anything like this requires a new package, okay? So this is a political problem, but we can only solve it technically. So they open sourced it and they donated it to the Eclipse Foundation. The Eclipse Foundation have done an amazingly good job, technically. That's all they can do, right? It's technical. They did an amazing job, really, really good. They released Java EE 7. Then in the Eclipse Foundation, they released Jakarta EE 8. Same exact code. Nothing has changed, right? They added new documentation and the new license, of course. But it's exactly the same, so it's backwards compatible. Then they did Jakarta EE 9. They changed Jakarta. They changed Javax to Jakarta. Same exact thing, just changed the package. So also very easy, backwards compatible, right? They made it as easy as possible for us to safely and easily move. And this is good because it took years. A big thing that you'll see in Spring Boot 3 is that all of this stuff is now using Jakarta. What this means for you is that if you are using these types, for example, with JPA or bean validation or whatever, then you're going to have a lot of compiler errors when you move to Spring Boot 3. Don't panic. It's fine. You're going to have to do the most insane find and replace of your entire life. And then it's over. It's done. No big deal, okay? So it's technically easy to fix, and there is a way forward. And it actually is a good thing because it means that these technologies, which have not updated in half a decade or more, will finally start to see new features, right? Wouldn't it be nice if JPA supported records, right? Something like that, right? Lots of really good possibilities here. So that's another thing you have to know. It's small. Like I write mostly reactive code. I don't use anything from Javax, right? I haven't in years and years and years, so none of my code will break. But some people do, and that's okay, and you just need to be aware that this will happen. It's a good thing, but it will be a little bit of a surprise. Now, I've got the request. I don't know what I'm going to do with the request. I could just say get whatever, the header names and get the let's just print out the header names. I don't care. It doesn't matter, right? I just want this there. Good. Okay, so we've got our handler. The next thing I want to do to make my application more production worthy is to make it observable. Now, observability is defined by two different things, right? We've got tracing, which is distributed tracing, and you have metrics, which are statistics. Historically, before, we had Micrometer, which did metrics, and then Spring Framework depends on Micrometer, and then Spring Boot depends on Spring Framework, and then we have Spring Cloud, which depends on Spring Boot, and then we have Spring Cloud Sleuth, which does distributed tracing. So this is a bit of an asymmetry. This cannot, I cannot do distributed tracing in Spring Framework or Spring Boot or Spring Cloud because it'll create a circular dependency, right? So now in Spring Boot 3, we've moved the tracing down into Micrometer and we've gotten rid of that. So now Micrometer, which is a very good project for observability, micrometer.io, Micrometer has lots of good adapters and integrations for all sorts of different time series databases like Prometheus and isn't that a Greek? Prometheus? There you go. See, I tied it together. We're here. There's a reference. I knew that. I was just testing you. Good. So there's all this there's all this synergy. I like that. Anyway, there's this nice integration for all these different time series databases like this, and also distributed tracing systems like OpenZipkin and anything supporting OpenTelemetry, right? Very, very powerful option. And we also have a new unified API, okay? So rather than returning this directly, I can wrap it in an observation, right? And I'll say by name. And I need to inject now a private final observation registry, right? Here we are. And there we go. Very good. Add this to the constructor arguments. Very good. So now I've got this registry, and I can now wrap this, and I can observe something in the context of that call. So when I do that, I'm going to just say return this, like so, okay? And Good, very good. So there's my new unified code. The nice thing about this is it's going to collect a metric by name, and if I do anything with this service, if this repository, imagine I was making a call to another microservice using the REST template or the web client or Kafka or something, I would also start or propagate an existing trace, okay? Very convenient. So here we go. If I go here to this one, so customer Josh, okay, refresh, 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 you know, just over and over and over, right? Okay, so now I can go to the command line here, or to the console, and I can say, okay, actuator / metrics. Oh, I don't have the actuator in the class path. I have to enable those, right? So expose, includes, show details for the health, and I'll enable Kubernetes probes as well, and then I'll just restart this, okay? Where's my truer? Thank you. Restart. Okay, so there's the endpoints. You can see there's nothing there. Let's go to the command line here. Okay. While true, done. Okay, good. So now I go here, refresh, come on, refresh. There it is, it says by name. And if I go here, I can see that I made 82 requests, and here's the total time, and the max duration of all of them, etc. Very good, very easy to understand. I get distributed tracing and metrics. That's a new unified API in Spring Boot 3, okay? This makes it easier to do both in the same consistent fashion. Now, friends, we've got observable, production-worthy, updated to use Jakarta EE and Java 17 code, right? I think we're ready to start moving to production, to start thinking about production. Here, my friends, there are two concerns. The first concern is, how do I containerize the application, right? And obviously, to this end, we have the ability to use something like build packs, right? Build packs are a great way to take an application, whether it's a .jar or a .war or .exe or Ruby on Rails or Python or Node.js or I can't say it, it's not a language. Anyway, moving on. You can do all those technologies and turn it into a container very easily using build packs. There's a CLI that you can download. But if you're using Spring Boot, there's also a Gradle and build plugin. So you can go here and Gradle W build boot image, right? That'll do it. Or if you're using Maven W, you can do Spring -boot build -image. Either way, you'll get a Docker container that you can then Docker tag and Docker publish to your container registry of choice. Remember, friends don't let friends write Docker files, okay? Use build packs. Trust me, nobody's going to come to you late on a Friday night and put their hands on your shoulder and say, great job, really, well done, right? Way to write the best Docker file. Nobody cares. You're wasting time, seriously. And you're going to get it wrong. You're going to get it wrong. It's going to be invalid within days, right? You're going to have some security bug that you're not thinking about. Just use build packs. That's my message to you, friends. Don't write Docker files. Just trust me, hair will come back. It's great, okay? Now, we have an application. We can containerize it like that. But what I want to do is I want to make my application as efficient and scalable as possible, my friends. And so to that end, I want to make it as efficient and scalable as possible. And there are some opportunities here that I want to take advantage of. Now, before we get too far down the road, I want to say that, first of all, Java is actually pretty scalable and pretty fast, right? Here's a very interesting blog from 2018. Which programming language uses the least electricity, right? And if you look down here, it is a chart of normalized global results for energy, time, and memory for different languages. And you can see, C is the most efficient and the most compile, energy efficient. Okay, Rust, of course, very, very good as well. C++, okay. Ada, who cares? And then Java, right? I mean, I don't care about Ada, do you? Do you know if people still use that language? I didn't. Right? Like, I thought that was, okay, anyway, Java, right? Java is not, it's, let's just say it's 2.0, okay? Call it very simple numbers. So C is the most efficient. Java is twice as inefficient. Okay, not great, but, look at the other languages. Here's C#, more than 3 times, right? You've got Go, more than 3 times, F#, Dart, JavaScript, TypeScript. Wow, TypeScript, what is going on, buddy? What happened? I thought TypeScript was JavaScript. What is this? I don't even understand how that's possible. Here's these two things, right? And then, look, I love Python, but, wow. That's 32 and a half times more inefficient, not efficient, compared to Java, right? So, okay, so Java is pretty good. It's pretty good. Now, there are two reasons for this. One is because of the miracle of the garbage collector, okay? The JVM garbage collector makes it so that I can write terrible code and get okay performance. I like that, right? Now, I will say, as much as I appreciate the Java garbage collector, I think it's just fair to say, I just want to point this out, it's not the original Java garbage collector. That honor belongs to this person. She is a product manager in New York City, but she is from, accept all cookies, Europe. I am from the island of Java, Indonesia, and I am a Java garbage collector, right? I just think it's fair. We just have to be honest and say she has the title first, right? And I love this tweet because look how many people liked it. That means that there are garbage collection fans, from like the Java community, and also actual Java garbage collection fans, and also geography and country fans and Indonesian fans, all together. The intersection, the Venn diagram right there, 19,000 people. Good. So the Java garbage collector is amazing, right? Super fast, super capable, makes it so we can do amazing things. That's one thing. The other thing that makes Java so fast and so capable is the just-in-time compiler. The just-in-time compiler is phenomenal. It takes code and it finds places in the code that are not doing anything dynamic. So reflection, proxy, serialization, JNI, all these kinds of things. And if it finds code that's not dynamic and it has run many times, it adaptively turns it into native operating system and architecture specific code. The just-in-time compiler is phenomenal, right? But the problem is, like I said, it can only do it for things that are not being very dynamic. Remember, Java, for all of its syntax warts and problems, is actually a very dynamic language, much more like Python and Lua and Ruby than C or something like that, right? Very, very dynamic language. It has a runtime. And so even though we don't think of it like this, you can actually create a Java-lang string that has Java source code in it, take the Java-lang string at runtime, when the program is running, you can compile the Java-lang string into a .class file, load the class file, write the file to a disk, load the class file into the class loader, reflectively create a new instance of the class, call methods on the class, all at runtime, after the JVM has started and is running, right? It's an amazing language. And this dynamic behavior is hard for the just-in-time compiler to adapt to. But if it can find something that isn't doing anything dynamic, it can optimize the code. So what if we could turn the whole program into native code, adaptively, proactively, before we compile? We would have to have some way to account for all this dynamic, fun behavior, right? And that's the promise of the GraalVM-native image compiler. GraalVM provides a mechanism that if you provide configuration files telling it where you're doing these dynamic things, it'll turn your application into a native image, an operating system and architecture specific native image. But the problem is somebody has to write all this configuration. Well, Spring is in a very good position here. Spring is the framework. We see most of the dynamic behavior, right, in the system because we are controlling that as the framework. So we can do a lot of that for you, maybe even all of it for you, right? If you're not doing anything too dynamic by yourself, then maybe it's already done for you. So let's take advantage of that. Let's go ahead and kick off a GraalVM native image build, right? Native compile, like this, like that. We'll let that run in the background. And I love the native compilation, but I'll tell you, my friends, that it takes a little while, right? And that time that it takes, I finally understand this famous, amazing cartoon from XKCD, right? I finally understand this joke, right? I never understood it before. The #1 program excuse for legitimately slacking off. My code's compiling, right? I didn't get this before. Who has a language that takes so long to compile that you can write, you can do stuff, Java is very fast, right? Most modern languages are very fast. So I understand this now. And actually, it is a problem. I'll tell you, it's a problem that the GraalVM native image compilation takes so long that I get distracted. I get bored. It's not long enough, unfortunately. It's not long enough that I can go to the bathroom or take a walk or respond to emails or make a cup of coffee or something like that. But it is long enough that I get distracted. I get kicked out of the zone, right? I'm no longer in the flow. And this bothers me because I just sit there like this, waiting for it to finish, bored. And I start to hear elevator music, you know? Elevator music. And I don't want to hear elevator music, but I thought, well, if I'm going to hear elevator music, wouldn't it be nice if everybody could hear elevator music? And so I went to the official GraalVM project from Oracle, and I said, please play elevator music during the native image compilation. And I said, look, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do, by the way. They're amazing. Very nice. And our friends from Red Hat posted a link to this video. I'm not sure if I can play it, but this is from the James Bond GoldenEye movie, right, from the 90s. And the soundtrack, one of the actual soundtracks is amazing elevator music. It's great, right? So I was like, okay, that's a good idea. And then somebody says, hey, I would add that using beeps, you know, like a beep in general, not only for the native image, really helped me to reduce development time. That's true. That's a good idea. Like a ding, wouldn't that be useful? My toaster will do a ding. Why can't our million-line or billion-line compiler do that, you know? Like, why not? And it makes a lot of sense. I think this is a very pragmatic, useful addition. And then we got this great response from this gentleman. His name is Fabio Nighthouse, I'm sorry. And he's a very nice person. He's a researcher on the GraalVM team at Oracle Labs, and he's also a doctor, previously at Google Colab and Matan Guitars, and he's in Potsdam, Germany, okay? And so he left this very nice message, this nice response. He said, go over here. Thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. And he said, anyway, I have prototyped a -- Josh Long mode, right? And so this is what that would have looked like. This is what it would look like, right? My -- Josh Long mode prototype for GraalVM native image, the official project, and then there's the context, and basically you say you say native image -- Josh Long mode, hello world, right? And then it would say music brought to you by Josh Long, right? And then it would have this, right? Spring. So yeah, I think that is a good future and a good feature. Anyway, I think that would have been nice, right? But then he continues, for some reason, I have the feeling my PR will be rejected, probably because of the copyrighted music. So on a more serious note, he continues, yes, we could add a ring bell when done option that prints the bell code after the compilation process. Okay, that's a win. We did it. Go. Let's go. So there's going to be like a ding, like a toaster, finally. So anyway, yeah, I think our build's probably done now. Let's go back and check. Oh, yeah, okay, so it took about a minute, right? It's not that bad, but it's bad, right? It's enough that I get distracted. Okay, so build, native image, native compile, service, very good, hit run. The port is already being used. Let me stop this here, okay? Restart, very good, look at that, faster than a light bulb, right? So less than 1/10 of a second to run the application. Very, very quick, right? If I just restart, very, very quick. I like it very, very quick. And that's fine. If you're doing serverless or something, this is great, right? But what I care about is actually, I care about this. Where's the process identifier? Right here, right? That's the process identifier. I'm going to copy that, and I'll go ps-o RSS this, right? Very good. So there's our native image memory. It's about 100 megabytes of RAM. Good, right? Really good. So I like this. This is a feature that is very exciting to me, especially since like 20 years ago, I went into a data center and I plugged in patch cables into the computers in the data center. Anybody here remember data centers? They're big buildings full of computers and they're freezing, right? So you have to bring a big jacket and stuff. I used to go into them a lot. That was the old days. Anyway, I plug in this patch cable and I go to each computer and like, how much RAM is it taking? Oh my goodness, like 2 gigs of RAM, right? Just for one like JBoss or something like that, right? Plus your one app in the JBoss or whatever, any application server. Lots of RAM. And I remember at the time thinking, gosh, wouldn't it be nice if we had more RAM, right? Back then we had 32-bit JVMs and 32-bit operating systems. So things were not as scalable and efficient. Today we have 64-bit. In theory, you could have even more RAM, but you don't need it because now you can go down, not up, right? Very, very small. So I like that. Okay, friends. So we've got ourselves a service. You know, the last thing I want to do is I just want to build a quick client, right? And so to do that, I'm going to use GraphQL, and I'll use the reactive web support, and we're going to call this client. We're going to open this up in our IDE, okay? So cd downloads uao client.zip. Very good. And you know, we're going to run this application. It's going to be a web app, but it's going to run on a different port. And this is just going to be a client that talks to our service, the service that we just built. Now, I could write a client. I could create a client by myself, but that sounds suspiciously like work. So instead, I'm going to use a new feature in Spring Framework 6 that allows me to just define an interface and get back the results, right? I need a pointer to the customer type. So I'm going to do something terrible, something that you should never, ever do at home, not even when no one is looking. I'm going to copy and paste some code here, okay? Paste this here. At ID, good. And I'll say publisher, customer, all, okay? And I want to define how this gets mapped from the client side. So I use a new annotation here called getExchange. And then I can create a Spring Bean to actually create that interface for me, right? So customer, client, and I'm going to create a reactive, non-blocking HTTP client using the builder here, right? Builder. And I'll say return HTTP builder dot base URL HTTP localhost 8080, okay? So there's my web client dot build, right? And then I need to, you know, HTTP service proxy equals HTTP service proxy factory. And most of the time, you don't have to redo all this for each one, but I'm going to do it, obviously, because I need to, you know, I only have one instance, right? And then you create the client, passing in the interface, like that, and I can just return. Sorry, what?
Second line, you got the full header.
21. Oh, thank you, base URL, thank you. Oh, good catch. So client adapter, web client adapter, WC. Okay, so I've got this very simple thing. Now I want to use that client to talk to my web service, right? So application listener, application ready event. Thank you, return new application listener, like so. And I'm just going to inject this, this customer client here, cc, and I'll say cc.all.subscribe, and I'm just going to print out the results as the application arrives, turn this into a Lambda. Okay, good. So we'll run that. That'll be fine. That's one way to talk to the downstream service. There you go. You can see the data. It started up. It talked to the web service. Not a big deal. The other thing I might want to do is to use GraphQL. Now, GraphQL requires a little bit of schema, right? So I have this folder here. And the idea with GraphQL is that it's a way to create a representation of the data that might be different from the way it was implemented in the back end. So I'm going to define my data types here, like name and customer and so on. And I'm going to define a endpoint that is it's basically a default standard that you have a type called customer that has a field, and these fields are the default root queries that you can make against the GraphQL schema. So I'm going to define a query called customers that is going to return data of type customer. I'm going to return more than one. That's what these brackets are. Now, of course, I might want to introduce another type, and I can do that here like that, right? So I can say customers, and I can actually even make it so that this returns a profile, for example, right? Well, I didn't implement that. There's no other microservice that implements profile, but just imagine that there was. Imagine that I wanted to call that for every single customer to get the profile data. So I can create a GraphQL, come on, it's weird typing at an angle, GraphQL controller, and I'm going to inject my customer client into the constructor. And in order to create that mapping, I'll just say query mapping, publisher of customer, right, customer. So this is going to map to the schema, right? I have customers, I have a query mapping endpoint, right? So return that, this.cc.all. Very good. Now, what about the profile? Let's suppose I had another microservice. Just imagine, okay? And I'm going to say, you know, that. Now I want to have a way to return the profile for each customer, okay, from another microservice. So I just create another schema endpoint, injecting the root aggregate type here, called customer. And I can just say return new profile c.id. Very good. Now, the last thing I want to do is I want to have a simple client that I can use to talk to this. So I'll say enabled equals true. Let's go ahead and restart that and see what happens. Compile, okay. Localhost 99D. Graphical. There we go. There's my simple endpoint. And you get, look at that, I get control space ability. All that work that we do to make HTTP and REST have schema, you just get for free with GraphQL, right? Now, notice that I'm getting the data back, but I'm not getting the profile data because I didn't ask for the profile data. Well, the profile data, if I want it, look, I can't just leave it unspecified. I have to specify the subfield. But if I do that, I get back the data. Now, of course, you're saying, well, this is inefficient. I'm making n+1, right? I'm making a call to the profile service for every single customer. Well, of course, I can rewrite this. If I have a more efficient way, I can use batch mapping, right? And batch mapping, the contract is very simple. Return a map of profile. So list of customer, like this, return, and I'm just going to say var m equals new hash map customer profile. Good. Here we go. Come on, import. Thank you. Computer, do the thing. So for var c, customer list, m.put c new profile c.id, and then just return m, right? So now I've changed the implementation, but the client doesn't know or care, right? It's now more efficient. I could call another microservice and say, return all the customers where the customer ID for the profiles is in this range of things. Look at that. My friends, we've only looked at a few features here today. Obviously, there's a lot that we didn't get a chance to cover, but I hope you learned something. Who learned something? Who had fun? Okay, very good. I appreciate you all. Thank you so much, my friends. Thanks for coming. I'm happy to answer questions, and have a great day. Thank you.